dam behind me was constructed to store water for irrigation for the horticultural research by Oregon State University. This concrete slab here was probably the first dam built in the 1930s, but it proved unsuccessful. So they built the corrugated metal dam behind me probably in the 1940s, but it proved to be too high, so they cut 2 notches in the dam, and it has stored sediment and changed the flow of water through this section. Since the dam was built, the university realized that it was causing ecological impairment. Cutthroat trout are found throughout this stream basin, and this dam creates a barrier to their migration. As you can see right now, it would be very difficult for a cutthroat trout to get over this dam. In the spring, we also find Chinook salmon juveniles moving downstream the Willamette River and out of the Willamette River and holding in little tributaries like Oak Creek. And so in the late 1990s, the university realized that this dam was causing ecological harm, and so it decided to remove it. And so now the plans are to remove the dam behind me and allow the water to flow freely through this section again and no longer be a barrier to the movement of fish and the effects on the aquatic ecosystem.
So we're standing upstream of a beaver dam looking at its pond, and we're on Oregon State University property, kind of like in the heart of Beaver Nation. And this is a tributary. This small stream here is a tributary to Oak Creek, and we have a highway adjacent to us, so we may get some road noise at this point. Today on this stream we have a dam which is about it's over 6 feet tall, which is quite large actually for beaver dam. And these start low, and then they are slowly built upon, and they are built in response to their local environment. So these are quite different than a dam that we would construct out of concrete and other materials. So when we look at beaver dams, the way they're constructed of woody material, organic material, the fact that actually this dam can be washed out and then replaced. So they are temporary features in many cases, or maybe there for a number of years. But this is quite different from the permanent dams that we try and put in a system, which are usually quite different in how they function and what they do. And the fact that they are barriers to organisms trying to move up and downstream, the fact that they have only a certain control on water heights to some level, just really limits what a human-built dam can do, as opposed to beaver that are responding with their dams to the landscape they're in. This dam is unique. We can go up and look at another dam and it will be entirely different. And we can look at another dam and they will see that they are working these dams into the landscape to fit the form of the channel and everything else. So they're really quite unique and really very hard to replicate in a human scale. So when beaver build dams on these landscapes, they start a process which is really quite unique and changes almost everything in the local environment. By stacking water up here, by creating these ponds, they create a small lake which then puts water out underground, under the surface, and then creates areas where plants of with all kinds of different moisture requirements can grow. And so you have this diversity of vegetation growing across this landscape. We also get water leaking subsurface through the underground environment to come out down below. And it's all been cleaned out by working its way through the soils. These ponds are trapping sediment, they're trapping organic matter, they are actually purifying water that is being released from down below the dams. So when we look from an ecological standpoint at beaver dams, and you keep in mind that these have been doing this for hundreds of thousands of years across North America, they just have these very strong ecological footprints on the landscape. They are unique and they are very powerful in the way they change everything out here. We find they sequester more carbon. So this has become a major issue today. So beaver ponds and the vegetation they support sequester a lot of carbon, which is one of the other benefits. So we can look at carbon, water quality, storage of water. We end up with water here that is stored in winter and released in summer through subsurface environments, sustaining base flow in streams. Then as the dam goes higher, the pond extends further up. And that water that is usually captured during periods of high flow actually is pushed out laterally into the subsurface environment. And when that occurs, Plant species of all kinds begin to see water in even very arid environments. So we see this moisture relationship build, which increases the productivity of plants on that particular site, but it also greatly increases the biodiversity. We see sedges, we see rushes, we see shrubs of all kinds, grasses of different species, all kinds of woody species. So the biodiversity begins to change dramatically when we have these ponds and the moisture that they provide in these terrestrial landscapes. So one of the features about beaver dams is that they will typically allow the passage of fish as well as eels as well as other organisms. Over thousands of years, Mother Nature has figured out that these species can move up and down these streams where we have beaver present in the system. And so they are not blockages in the sense that they terminate the movement of species. They actually allow species to move up and down. So they have this very important role, and we should not consider beaver then as being pests in the landscape. We have treated them like they are pests, and that has been the history. But we ought to realize that before we arrived on the scene, beaver had been working and living in these ecosystems along with Native Americans for many thousands of years. And these were very productive stream and aquatic ecosystems. And returning that productivity is one of the things that we really ought to be thinking about with regard to getting beaver back in the landscape. They're a very necessary component to really improve what's going on out here. And the science community has realized in recent years that these are keystone species. They're not varmints, they're not problem species. They are indeed a keystone species that promote all kinds of ecosystem benefits. So again, when we look at beaver types of dams and human structures, we really ought to be thinking about them quite differently, how they function and what they do. So they're not equivalent, they're different. Today we consider beaver as a keystone species. It performs important functions. It supports wildlife of all species. And so they are just an incredibly important component to have on the landscape, and we need more of them to recover those habitats.